Hi and welcome back to Short's classes. Today we are going to be dealing with the chapter Analysis of General Function Model. Let's begin. We are given a consumption function c equals to a plus by with a greater than 0 and b lying between 0 and 1. Now we need to find its marginal function and its average function. Let's see how to do this. We find the marginal function by differentiating dc. So therefore dc by dy equals to b. And the average function can be found out by dividing c with y, which comes to a plus by y. Now let's see how to find the income elasticity of consumption, ECY, and we will also determine its sign assuming y is greater than 0. As we know from the formula that ECY equals to dc by dy whole divided by c by y. This comes to by by a plus by greater than 0. Seems very easy. Now let's find how the consumption function is inelastic at all positive income levels. Since by is less than a plus by, therefore it follows that eta cy is also less than 1. Hence, our problems are solved. Moving on to a tougher question. We have to find the point elasticity of demand of Q equals to K by P to power N. Now, how does this elasticity depend on the price? And also we will find the special case where N is equals to 1. Notice, since Q equals to K P to power minus N, with dq by dp being minus nk p to power n minus 1 and q by p equals to k p to power n minus 1. Therefore, the point elasticity of demand, that is ED, equals to minus n, which is a constant. So since ED is equals to minus n, therefore we find the first answer. Does elasticity depend on price in this case? Notice we don't have a price term in this, so the answer will be no. Now for the second case, that is a special case where n is equals to 1, the demand function q equals to k by p, which plots a rectangular hyperbola that looks like this, will be found with a unitary point elasticity everywhere. Now we'll do another sum. Now we need to find the price elasticity of demand and income elasticity of demand of this question. Here Q has been given as Q equals to 100 minus 2p plus 0.02y, where Q is given as a quantity demanded and P is the price and Y is the income. We are also given with P equals to 20 and Y equals to 5000. Now we will find the price elasticity of demand. The price elasticity of demand ED equals to del Q by del P into P by Q, where the partial derivative with respect to price is minus 2 and Q equals to 100 minus 2 into 20 plus 0.02 into 5000, and upon solving we find that to be 160. Therefore ED equals to minus 2 into 20 by 160. which comes to minus 1 by 4. Now we'll do number B, that is the income elasticity of demand. Now the income elasticity of demand is given by eta equals to del Q by del Y into Y by Q, where the partial derivative with respect to income, that is del Q by del Y, is equals to 0.02. Substituting the relevant values, we find eta equals to 0.02 into 5000 by 160, giving us 0.625. Now we have a different set of question. Over here we are given with the supply function of a certain commodity, that is Q equals to A plus BP square plus R to power half. Now we'll find the price elasticity of supply eta QP and the rainfall elasticity of supply EQR. Eta equals to dQ by dP into P by Q, that is the formula we have. So we find the dQ by dP, which is 2 BP from this question. Now substituting this in this equation, eta equals to 2 BP into P by Q, that is 2 BP square by A plus BP square plus R to power half. Notice we have Q out here, so we'll be substituting this whole value in this question in order to find our answer. Now we'll find EQR. EQR similarly has a formula dQ by dr by R by Q. Oops, I have made a mistake. Just a second. As I said, just a second. Yeah, EQR equals to dQ by dr into Q by R equals to half R to power minus half R by Q. How did we obtain this value? We find dQ by dr, which comes to half R minus half R to power minus half, by differentiating this function and again putting it like the previous case, we obtain half R to power half by A plus BP square plus R to power half. Now we have an interesting question. Over here we are given a foreign demand of our export X, which depends on the foreign income YF, and our price level P is X equals to Y to power half plus P to power minus 2. Now we need to find the partial elasticity of foreign demand for our exports with respect to our price level. Let's see how to do this. Eta XP equals to del X by del P by X by P. This equals to a minus 2 P to power minus 3 by YF to the power half P square plus 1. Very easy, because this is only our question and this is the only answer that we need to give. These are the questions that you usually get for analysis of general function models. Further, we'll be doing tougher questions in our next video. So stay tuned, like, subscribe and press on the bell icon for notification. Thank you.